All right, so let's dive right in. We all talk about the cloud, right? It's a term we hear all the time. But today, we're going to look at how that exact same idea is fundamentally rewiring the massive global network that connects every single one of us.
Think about it for a second. You snap a photo, you save a file, you back up your phone, and it all just disappears into this invisible, kind of magical place. But have you ever stopped to wonder, where is that place really?
Well, here's the thing. It's not some fluffy white thing in the sky. It's actually a very real, very physical network of huge data centers, just packed with servers, storage drives, and a ton of software. Basically, it's this giant shared pool of computing power that you can tap into whenever you want, from wherever you are, as long as you have an internet connection. So what's the big deal? What makes this cloud model so revolutionary? Because it's about way more than just storing your photos online. It's a completely different way of thinking about computing, and it all comes down to a specific set of roles.
You know, this didn't just appear out of nowhere. It's been an evolution. I mean, you can trace it all the way back to the giant mainframes of the 60s, then to the virtualization boom in the 90s, and a huge moment in 2006 when Amazon Web Services launched the modern cloud as we know it. Each step made things more flexible, more like building with digital Lego bricks, which leads us right to today and the era of cloud-native telecom.
And this is where the money part gets really interesting. In the old days, if a company needed more computer power, they had to go out and buy a ton of expensive servers. That's a massive upfront cost, what the business world calls a capital expense, or CapEx. The cloud completely flips that on its head. It turns it into an operational expense, or OpEx. It's more like a utility bill. You just pay for what you use, and you can scale up or down pretty much instantly.
And you can't just call anything the cloud. For a service to be truly considered cloud computing, there's actually an official checklist. It has to have 5 key ingredients. You need to be able to get resources yourself, on demand, access them from anywhere, share them from a big pool, scale up or down in a flash, and only pay for what you actually use. That's the secret recipe.
Okay, so we've got the rules of the cloud down. Now, let's connect all this back to the absolute backbone of our digital lives, telecommunications. For these companies, this move to the cloud isn't just a cool new feature. In a world with fast-moving tech giants everywhere, it is quickly becoming a survival strategy.
And believe me, this isn't just some small, niche trend. Just look at this finding from GSMA Intelligence. More than half of the world's telecoms are planning to move their core workloads, and we're not talking about their websites. We mean the guts of the network, the essential stuff that makes your calls actually connect to the cloud. This is a massive industry-wide shift. And this isn't some 5 years from now prediction. It's happening as we speak. Right now, 2/3 of telecom companies are already tapping into the cloud's power to crunch data and make smarter decisions about how to run their business.
But they're not just diving in and hoping for the best. Nope, they're being really strategic about it. Over 80% are starting with what's called a hybrid model. This means they blend the security and control of their own private systems with the incredible scale of the public cloud. It's like getting the best of both worlds.
So what's the big push? Why is everyone making this move? Well, it's about staying competitive. It's about cutting costs, sure, but it's also about speed, being able to roll out new services like 5G way faster. It's about being able to scale in an instant for, say, a huge live event. And it's about building the foundation for what's coming next, things like AI and edge computing.
Okay, this all sounds great in theory, but how does it actually work? I mean, how do you take a giant, sprawling physical network and turn it into flexible software that just runs in the cloud?
Well, the magic behind all this has a name: Network Function Virtualization, or NFV for short. The core idea is actually brilliant in its simplicity. You take all of those specialized, purpose-built, super expensive hardware boxes that run the network, and you just replace them with software that can run on any standard off-the-shelf server.
The absolute best way to understand this is to think about your smartphone. You used to need a separate camera, a separate GPS unit, a separate music player. Now, they're all just apps. NFV does the exact same thing for telecom networks. The job of that physical router, it just becomes a piece of software, an app, if you will, called a Virtualized Network Function, or VNF.
This software revolution also transforms the two brains of a telecom network. First, you've got the OSS, or the Operational Support System. That's the technical brain, the part that manages the network itself and keeps the lights on. Then there's the BSS, the Business Support System. That's the customer-facing brain. It handles your bill, your orders, your support tickets. Moving both of these to the cloud makes them way faster, more automated, and so much more adaptable.
All right, let's bring this all home. We've talked about a lot of technical, back-end stuff. So the big question is, why does any of this matter to you? Because this invisible upgrade is what unlocks the future. When you combine the insane speed of 5G with a cloud that extends right to the edge of the network, super close to you, the lag, or what engineers call latency, just plummets. And that is the secret sauce for real-time applications that need an instant response. Things like autonomous vehicles, truly immersive AR and VR, and smart factories.
And the future isn't just faster, it's smarter. When you embed AI into every layer of this new cloud network, it can actually predict problems before they even happen. The network can literally heal itself, automatically rerouting traffic if it thinks a piece of equipment might fail. And for us, that means our connections just become more reliable and resilient than we ever could have imagined.
So, that's the big picture. The entire foundation of global communication is shifting away from clunky, physical hardware and towards intelligent, adaptable software. And that leaves us with a really fascinating question to think about. As our networks become as dynamic and creative as the software that runs them, what incredible new possibilities will we unlock next?